Hello there, welcome to Unit 3. In this lecture, we're going to talk about priority queues. So first of all, what we are going to introduce what is a queue, which the text structure is probably the most common one to us since we are used to use it on our everyday basis. So then if we have like a waiting area, what we're going to do is place elements inside that area. So when an element comes, it will go into the top of the area. Then when a new element comes, it will wait its place behind that element, and so on and so forth. And then when we want to take elements from that area, what is called as unqueuing. So what we'll do is just take the first element of the queue and take it out. Then it will come the second element, and so on and so forth. What we want to do now is implement a priority system in order to make some elements more important than others. So what we're going to do now is that each element will have a priority number assigned, and in this case we are going to consider that the lower the number, the higher its priority. So in this first case, since the queue is empty, then no matter the priority, the element will go in the first place of the queue. But when a second element comes, then that priority will be compared to the rest of the elements in the queue, and its place will depend on that. In this case, since this new element has a lower value than the one at the head, then it will take its position. The new element will be the new head, and the previous first element will be the second. Now when a new element comes, the same will happen. In this case, since this new element has the same priority as the first element, then it will be beyond the 5 priority value element, but it will take the following place to the next one with the same priority. So it will take the second position. And then when the times 2 comes from unqueuing, then we will follow the same procedure. The first element at that moment in the queue will be the first one out, and the process will be repeated until the waiting area is empty. So how are we going to compute this? Our basic operations will be considering that we represent the priority queue with the letter Q. We will implement a function for adding values into that queue. We will receive the value to be added, and will be placed inside that one. Also, we have a function for computing which is the minimum value from inside that queue, and we'll just return that value, and we will trigger an exemption in the case that the queue is empty, because of course if no elements there are in the queue, we will not be able to compute a minimum. We will have a similar function called remove min that will not only look for the minimum value, but also will take it out of the queue. And of course, it will trigger an exemption in case that there's no element in the queue. And finally, we'll have a function for computing the length of the queue, that is how many elements are there in the queue. And that function, what we'll do is re-implement the standard length function in Python classes. So how are we going to compute this? There are several ways of computing this based on list, both sorted and unsorted. If we take, for example, an unsorted list, adding into that list will be just appending into the list, since the order doesn't matter, and that will have a constant const of just the append function. But if we want to compute the minimum value, or removing the minimum value, which also takes implicitly the compute of the minimum, then the cost will expand to a linear cost, since we need to go through the whole list in order to find which is the minimum value. If instead of unsorted list we take the sorted list, it will be more or less the same. Computing the minimum will be constant, since we have the minimum at a certain position, but adding a new element will imply to go through the whole list. Therefore, these implementations are very inefficient due to having at least some operation with a linear cost. What we're going to do is, at the next video, we're going to see how to implement this using, at a worst case scenario, a logarithmic cost. And we will do so using the data structure known as binary heaps. That's all for now. Thank you.